Hi friends, today we are discussing about high frequency capacitors and it is the session 6 and we go to learn about this session is the concept of high frequency capacitors. Objective is we will demonstrate here RF behavior of capacitors, we will describe about the problems associated with the capacitor and we will describe the construction minimization parasitic effects. And here we at the end of the session the learning outcome is how does an ordinary capacitor behaves at a micro frequency, and also we will understand and work with signals in different fields. So if you are thinking about the introduction, so RF circuit always depend upon the capacitor. This capacitor is used to tuning of filter, for matching network, for biasing of active transistors. So these three are main things when we are going to use in RF circuit. So for that we need to understand what is their behavior at high frequency. And if we are coming to elementary idea, so we know C equal to epsilon A by D. So what about epsilon? Epsilon is the permittivity of the dielectric, A is the area, so here is the area, A is the area, D is the distance from one dipole to second dipole. And also we can write like this, we know epsilon is equal to epsilon 0 epsilon r. So it is A by D. So where A is the plate surface, already we know from the 12th class, but I am just describing this. Now if you are coming to session description, there will be no current flow between the plates, current not flowing, only charge storing. Now at high frequencies the dielectric materials become lossy. So if it is lossy, the impedance of a capacitor retained as a parallel combination of conductance Ge and suspectance omega C. So we can write like, if you are thinking about capacitor, then if it is a high frequency, then we need to add here one, what is that, conductance. So this conductance is Ge and the susceptance is omega C. So if we are thinking about impedance, it is 1 by G plus J omega C. If it is only for a low frequency application, we can neglect here G. But if it is a high frequency application, we can write here Ge. So this conductance is applicable only for the high frequency. In this expression, the current flow DC is due to conductance. So conductance is always we can write sigma A by D. So what is sigma? It is the conductivity of the dielectric. So now we can write, if we are taking about the loss tangent into consideration, then it is tan delta S equal to omega epsilon by sigma dielectric, and G can be written as, from that we can write, if you will solve all the things, so G equal to sigma DIEL A by D. Also we can write omega epsilon A D tan delta S, or we can write omega C tan delta S. So that means if loss tangent increases, at that time the conductance is going to decrease. So that is most important part of the thing. Okay, and if capacitance increases and frequency increases, then conductance will going to increase. Okay, so it is most important terminology we are using for high frequency application for capacitor. If you are thinking about the equivalent circuit, we are adding one, here is the capacitor, now we are adding one resistor. So what is that resistor? Parallel leakage resistor. So leakage will come into existence because of radiation. So we can write leakage resistor assumed to be loss tangent. So that is also known as your loss tangent. In reality, this factor may significantly depend upon the operating frequency. In a data sheet, instead of tan delta S, it is indicated as ESR. ESR tends to 0 or tan delta S tends to 0. Capacitance is temperature dependent. It is most important point. If you are coming to RF microwave circuit also or a general circuit, capacitor is temperature dependent because it depends upon the dielectric. Okay, So it is more about your, and what is L and R? That are known as your stray resistance and stray inductance, these two. Okay. So now if you are thinking about wavelength and frequency, so always wavelength and frequency is equal to Vp. Why Vp? Because we are coming to a medium. If we are thinking about medium, then it is phase velocity. If we are thinking about the only means free space, then it is C. C means 3 into 10 to the power 8. It is known as your velocity of light, means it is equivalent to the velocity of light. But we are always, if the medium is not air, the speed will be lower than C. So that means if you are thinking about any medium, then Vp equal to C by square root square root of epsilon r. Okay. So this is most important relation to find out the things. Now the self-assessment questions are, I have given two self-assessment question here. High frequency capacitors are designed to have what? A, B, C, D. The parasitic effect in a high frequency component include what? So I have given the options. Please find out the answers. Now for terminal question, these are the terminal questions and important questions. Whenever, if any one of the faculty, they can put this type of questions only. Now if you are coming to reference books, these are the reference books and the site of wavelengths. Okay. Then this is the end of the high capacitance session, and we can now it is for me to make you thank you, and on behalf of Keele University, I am giving you thank you and appreciation. Thank you.